In continuation to the last week's inaugural lecture on the overview of National Building Code of India, which is one of the special publication of the Bureau of Indian Standards. In today's second lecture, we'll be focusing on the Part 4 Fire and Life Safety of the National Building Code of India. For the built environment and for the buildings particularly, be it new or existing buildings, fire safety is such an important and essential criteria, and it will be more important that building owners, building professionals, owners, they follow the provisions given in the building code, and then they start constructing their built facilities that way. So before we begin by inviting the speaker of today's session, who is Shri Sandeep Goel, an eminent practicing engineer, MEPF engineer, or a professional engineer for over 30 years working in this field. Myself, Arun Kumar, the member secretary and head of the National Building Code division within Civil Engineering Department of BIS, would take about 10 minutes time to quickly show to all the audience present here, particularly students and the faculty, what is that we typically see in buildings and built facilities as fire safety measures. This particular screen is giving you a shortened version or nothing but the guide. In the last week event, we were told by some of the students that the building code is quite big. Where should we go and see? Where are the provisions, etc. For your own convenience, through this QR code, you will be able to download a 40-page document, which is nothing but a guide to use the National Building Code. In about 1 to 2 page, all the 33 chapters of Building Code have been enumerated in a pictorial as well as a short text format. So this is for your information. And typically in the buildings, we have been seeing a variety of firefighting appliances. If it is a small residential building, typically we don't have anything except maybe an extinguisher. If it is a complex building or a high-rise building, we have multiple of such appliances. Let's just see what is the Indian standards which we have made. On this particular screen, you see the first aid firefighting extinguishers. Some of them are handheld. They start from 1 kg, they go all the way up to 11 or 12 kgs. And there are some bigger versions which are nothing but wheeled fire extinguishers. They are typically seen in large offices and importantly in business buildings and more importantly in industrial buildings. There are Indian standard specifications for such first aid firefighting extinguishers as given on the screen. And then going ahead, you'll be seeing, say, if fire or smoke has happened, somebody should let know other occupants of that building. How do we do that? By using any of this manual call point. By pulling that particular trigger or by breaking that glass, a hooter will make its noise and it will alert everyone in that particular building that there is some issue with fire or smoke. It's a warning one. So that's called its manual call point. And if people are not there in a building, they have locked and they have gone out somewhere, but there is some issue, somewhere a leakage or somewhere there is a fire or a smoke which is happening, then these automatic fire or smoke detectors will start in, they will keep sensing 24/7 round the clock. And because of their sensing abilities, they will give a signal to the controller, and from that is a machine again, and from that controller the owner of that facility or that particular building will get a message, and he is going to send a team of person to see what is down, what is at fault, or what is there a real fire or smoke, what is that, he is going to take action. And all these are possible both as a conventional analog type fire alarm system or through automated fire unaddressable fire alarm system. In the addressable fire alarm system, apart from simply getting a sound of an hooter, a person, that particular representative of the owner, will take a microphone and he will be informing. Ours is a 7-story building. In the third floor, near room number 208, a fire or a smoke has been detected, and all the other occupants need not do anything. That particular floor number, people in that particular floor and those above, you please proceed through so and so wing, get out of the building at the earliest, and accordingly whatever should be the need of action, that can be done using this addressable fire alarm system. And there are variety of other detectors, say for example flame detector or carbon monoxide detector, response indicator, everything. There are variety of products, and depending on type of building, hospital building, school building, multi-story residential building, industrial building, factory building, non-polluting building, polluting building, so all these Indian standards are going to guide you which type of product should be used for which type of application. Apart from automatic detectors, we also have automatic sprinklers. On the top line, you typically see a variety of sprinklers, be it pendant sprinkler, which is facing towards us when we look up, or upright sprinklers or sidewall sprinklers, and even concealed sprinklers. They are all operating because of a metallic fuse or a glass bulb which has got a defined temperature, after which it will break and water is going to come in, and automatically near that particular seat of fire water will be thrown by one or two sprinklers and fire will be doused on its own. There are some special types of water curtain nozzles and mist sprinklers and even early suppression sprinklers, for which again respective Indian standards are available with the BIS. Going ahead, these sprinklers cannot work on their own. They have to be connected through a network of pipes. So typically we see all these red color pipes in our own institutes and colleges and hospitals. This is nothing but a sprinkler system. IS 15105 is going to tell you what should be the size of that particular pipe and what should be the amount of water and at what speed and at what particular pressure water should be maintained round the clock, so that automatic sprinklers can detect and function, they can function. And those particular pumps need a pump controller. The standard is going to explain you about what are those pump controllers, manual, automatic, and what is the electricity supply, etc. Those are all given. And similarly, apart from sprinklers, we need pumps for hydrants or other firefighting appliances also. This is again hose reel is what we typically see in most building. Hose reel, that particular box, if you open and see, there'll be this particular canvas made or PVC made or even nylon based tubes or hoses. And then there will be some hand controllable devices or other appurtenances as given in IS 884901 and 952. So these are all are required depending on and the length of such particular hose reel is also such that you can go up to 20 meters or even 30 meters. It depends on your length. That is why the building will have number of such hose reels in a given floor also. It can go both on left as well as the right direction also. I mean, this particular picture is only depicting what is that particular hydrant box, how it should be kept accessible. Never put a lock, proper lock. But like this sort of an Allen key type of thing only should be there, so that a fireman or that particular deputy warden or that in charge of the building can open that particular hydrant box, pull out the mechanism, and he can start fire. If you leave it open, things may go wrong also, or for cleaning purposes, or things can be moved here and there. For that simple reason, a mechanical lock is suggested in the standard. And there are other equipments which are being used by firemen, be it an axe, fireman axe, or a ladder as per 4571. In petrol pumps, we typically see these buckets of sand, etc. And then hydrant boxes of variety of shapes and colors and size. In industrial buildings, we have multiple such water throwing mechanisms or foam throwing mechanisms. They are called as water monitors. IS, there is an Indian standard 8442 and 15811. They are giving the specifications for them. Similarly, landing valves we will see in various buildings. They can be only one headed type or twin headed type, straight or angled or oblique, made of gunmetal, made of aluminium. So variety of such requirements and options are possible as per 5290. And this is what we typically see in a building in a firefighting shaft also. We used to see last week Mr. Pant, Sanjay Pant, the DDG, was mentioning about three components, namely fire exit discharge and exit access. And in that particular firefighting shaft, this particular wet riser with a hydrant system is always available. The code, building code, is also talking about what is the requirement of a fire pump room, where all the time under positive pressure water is readily available for the pumps to function. And there are other options of pumping also, but the code is giving restrictions on using these types of negative section as well as the axial pumps for use in buildings. Only for particular buildings these are permitted. For most of the other buildings only positive section pumps are permitted. This is again another sketch. Some of the postgraduate students in mechanical engineering and civil engineering must be using it, or they must have seen these types of drawings wherein at basement or below ground levels you have water storage tank, and just above it you have these pumps and movable impellers, their control switch, etc. Just to depict how this all these engineering things are going to work. So whatever we have read in our fluid dynamics or mechanics of fluids, etc., those will be, and more importantly in our plumbing services, those will be put to practice for this active firefighting suppression systems. And there are fireway inlets. Fire brigade can come with their tank, with their fire engine. They may have water, they may have limited water, they will have excess water. They can pull from water from your building, or they can supply water to your building. So that way there are multiple heads of water inlets are given in a particular building. So these are all active measures of fire has happened and then you quench it. How do you prevent fire? That was also spoken last week by Mr. Pant. So passive measures are one such mechanisms. So one way is that wherever you are puncturing a wall or a slab or a beam or a column, you should fill that particular annular gap using fire stop materials, for which 1248 standard is there. This is what in a typical curtain wall is going to have called as a perimeter fire barrier systems. In the BIS committee CD 36 has made the requirements of specifications for this particular performance. The buildings are so huge, they have to perform for temperature as well as for fire characteristics also. So this is going to help us if the products are performing and installed as per 18190. And new standards are likely to be formulated very soon on smoke curtains and fire curtains. As you can see on the top figure, when you have an atrium like scenario, and if there is a fire or smoke generating from one level, how you can protect the other levels. There is an arrow coming down. So these particular smoke curtains and fire curtains will come into operation. They will ensure that a non-fire area is not flooded by fire or smoke. Typically, you can see smoke barrier in your metro stations. As you see this purple color sticker, that glass, plexiglass material, it is nothing but a reservoir which is going to hold the smoke. It is particularly used in openings where you are connecting one level to the other, say from platform level to concourse level, or even can be used for any multi-level staircase also, if two floors have got a large cutout in between them. And this is similar to an extinguisher. Houses should preferably have a fire blanket also, so that when you do a kitchen cooking, now for kitchen fires this will help. And even this fire blanket is also being used by some of the industries. Let us hear in a short while from Mr. Sandeep Goel what are the other and particular uses of all these firefighting appliances. There are Indian standards for hazmat vehicles, hazardous material vehicle, as well as for turntable ladders, how they are put into operation. So wherever possible, the BIS, along with the support of various technologists in the country, we have tried to make Indian standards, even on fire tenders which are used in a mountainous region, in terrain region, and also in airports. You will see special types of fire tenders in operation. So this is just an this particular set of pictures. I thought we might have seen some of them in various buildings and projects where we have been going. But what are the technical requirements? How these things have to be put to right use? You should not do an undersupply of thing or an oversupply or over engineer your project also. Use the correct amount of safety mechanism to the amount of fire vulnerability. And how is that? That is all given through part 4 of fire and life safety, supplemented by the standards made by CD 22 on firefighting and CD 36 on fire safety committees of Bureau of Indian Standards. With that, I will stop here from the Bureau of Indian Standards, but I would request Engineer Sandeep Goel to take over and give his words of wisdom. As I mentioned a few minutes back, he has got over 30 years plus of experience, and he has done numerous projects of various sizes, not only buildings of residential or commercial, but also unique projects, even tall buildings, both in the country and outside of the country, also underground structures, above ground structures, challenging structures, etc. You can see more of his CV, etc. from the LinkedIn also, but he's also been a faculty for a long time in the School of Planning and Architecture in New Delhi. For about 18 years or so, he was a visiting faculty there, and he's a co-writing committee member for more than 22 years, if I can say correctly, because that is what I am also associated with the Bureau of Indian Standards. I request Shri Goel Saab to go ahead, please.
You can sit. So could you know? That's fine. Yeah. Good afternoon, everyone. I think it's an honor again back to BIS for sharing the inputs which we have learned over many years. And unfortunately, many of you I cannot see, I cannot interact with. But yes, some point of the time our paths will cross. Maybe we'll meet in another conference, in another lecture, in another series of discussions ahead. My name is Sandeep Goel. I come from a consulting organization known as Proion. We are based in Delhi, Mumbai, and Noida. And we are typically MEP consultants. One of the other portfolio which we are very passionate about is fire and life safety. So while we do MEP, mechanical, electrical, plumbing, fire protection design systems for different types of projects, one of our other contribution to the project remains with fire and life safety as well. So the whole idea remains, and I understand a lot of you are from the students background, so it will be nice for me to kind of bring across to you simplicity in the design rather than making things more complex. So the slides are going to be showing up. Unfortunately, it's a animation somewhere we are using that might delay a little bit, but I'll still try to make things as much simple as I could. So as you can see, the objective of the code, and fortunately I've been there for 24 years, is a very, very collaborative approach is to make the code, which is number one, adaptive. If we bring out systems and technologies which are not adaptive, people will not be encouraged to use the code, and they will really try to find a shortcut. If you have all the conviction and the correctness in the code, I can tell you from my good experience of 30 years, people would like to follow the codes. So, as part of the fraternity, it's our duty to make codes which are implementable, adaptive. Number two, code should eliminate any anomalies. The code in one section to the code in the other section should not be having anomalies and interpretational issues, which becomes a very significant problem for many of the designers, because by the time they land up doing the project design and the anomalies are looked into, it is realized that there are certain issues on which the design has to be looked into again. The other thing which comes around is basically the terminology. In any given language, computers, what we learned when I was in class 8th, when we started it, syntax becomes a very important tool. The clarity of a syntax is very important for the purpose of talking to a computer. Similarly, syntax becomes very important in a codal perspective. When you're using terms and technology, terms and English in the code, it has to be very clear and it should not be casual language. Sketches is one important thing. In fire safety, electrical distribution plays a very important role. And eventually, as we move ahead, we see buildings which are very large and complex. We will look at performance based design as the society moves ahead. But as of now, the society is primarily on the prescriptive design status. We are breaking up the fire safety into various parts. Fire prevention is one of the most important part. It means most passive way of doing a building so that the overall general requirements of fire safety are being taken care of. Whether it is compartmentation, whether it is in terms of the glazing, surface interior finishes, sorry, planning of the overall services in terms of its placement, it should not give an opportunity for the fire to happen. If your electrical systems are correctly done, if your plumbing services and electrical services are properly distanced, and you do not have a leaking pipe on the top of an electrical panel, you have the right kind of a strategy of safety distances to be maintained, the fire to begin with will not happen. So, fire prevention, as the word says, prevent the fire to happen. Now, as we all know, we may not be successful in our goal. Fire might occur. The next main objective for the mankind obviously will remain life safety. People should not lose life. Our loved ones, our people whom is family, we should not have any loss of life. People should be able to egress out of the building safely. And that is a goal I think we all should carry in our heart and mind as we visit various projects. You are very important for your family. So if you do not take care of your own safety in terms of knowing the exits, knowing what you have to do during distress, I think the overall cost of being casual will be very high for you and your family. So life safety becomes very important. Architects have to plan the things correctly. But let me tell you, as society, we also have to be equally conscious. Just by making blueprints, we cannot make life safety happen. So people have to be conscious as well to be saving their own lives and people who are around them. as we as we travel air, we always understand, take care of your safety and the safety of your neighbor. So I think that becomes a very obligations for us to be in this society. Fire protection is for the purpose of saving the property. Of course, once we are able to save the life, property protection is equally important. If you talk about property, I feel data centers are one of the most important properties, if you ask me. They hold a lot of information in it. Any vulnerability to a data center leads to collateral damages in a multiple way. All of us have computers today and mobile phones. If you lose your computer or your mobile, you know how difficult it becomes. Similarly, when you have got buildings which is storing data, fire protection of those buildings becomes immensely important. Of course, hospitals, of course, hotels, of course, offices. In all this, we cannot say this building I can afford to lose. No building we can afford to lose as well. Then, of course, additional occupancy wise requirements we have to provide for. Now I'll give you some now nice pictures so that you can, the thing starts interesting. You've got buildings and projects. Buildings which are big, buildings which are tall, and then buildings which are complex. So you have got buildings, and we visit these buildings in our day-to-day lives. Somewhere or the other, we are seeing those buildings as we travel in the city or we go from city to city. And then some buildings we are fortunate to see, which are basically big, tall, and complex, all put together in one box. You can see this Absolute Towers in Canada. It's a big building, it's a tall building, and it is a complex structure. So, of course, the building is twisting towers. It appears on the Council of Tall Building and Urban Habitat as some of the iconic twisting towers in the world. So, you can imagine how the egresses of these will be planned. And I'll go to Arunji. In case there is a staircase which has to be planned in this building on the facade of the building, you cannot imagine to do that. So one can see a twisting tower will never be able to have a staircase without being in the core.
Yeah, that's right.
Then we have this great project from India in Colombo. It is known as ITC-1, and it has got two towers with a sky bridge of ITC made by L&T in the foreign land of Sri Lanka, Colombo. I think it's a matter of great pride that we participated in this project. Two towers, and as you can see, the bridge in the middle has got a swimming pool on top. And let me give you more wow factor. Beneath the swimming pool is actually the restaurant. So what you see is an infinity edge swimming pool which goes into the oceans, because this hotel is on the ocean side. And now the real picture is that we have got problems in which all of us work as civil engineers, mechanical engineers, electrical engineers, construction engineers, low voltage engineers, and everybody is looking at the building in their own fashion. I like this picture the most because when we were kids, we never realized what this picture is all about. But as I have engineers in my office, we work together, I realize that I've got a lot of blind men in my office who look at buildings in a different pattern and not able to see the building as a whole. And I think the elephant is the one who gets the misery of it, because the treatment which the elephant is getting from the blind man is poor. So I think this is where we lack, and this is where we have to be with a holistic approach for the buildings we are designing. And how do we do that, sir? We do that by the books. And I am always very fond of saying my National Building Code of India, but I also appreciate my neighbors' publications which come from all over the world, whether it is whichever country. A while ago, we were discussing with Mr. Pansar and Arunji on global codes. I think we should take inspiration as well. It's not just that we would like to compete with them. We want to be the best in India. And as I said to Mr. Pansar also, that as I said to Mr. Pansar also, the objective remains that we see what's happening globally. Today, I'll give an example. EVs are evolving. We all have to learn from each other. All the countries are looking at each other, trying to learn technologies of electric vehicles. India is no far behind, but the population in this country will drive the EV up the hill, because we're going to be one of the bigger consumers of EVs as time comes. So codes and standards, we have got great books, we have got the international publications, we have got references of documents which we definitely should see as a reference document. But of course, India has to do the way it has to do. So typically speaking, this is how it goes about, that we have got this. And most importantly, I am a little worried that today our young people do not carry too much of data with them. And they feel, I will always use the word, that they feel, I think, I feel, mujhe lagta hai. I think these are some things which we should avoid in our conversation, because feeling and thinking doesn't work. It's the data which makes you go. And I like this the most, that without the data, you're just having an opinion. You have no backup of what you are wanting to say. Of course, a lot of people in fire safety feel that this is not going to happen to me and I'm going to always be safe. And I would like to live on the edge. I would like to take the life as a challenge. But believe me, my dear friends, as you grow old in your life, from your 20s to 30s to 40s and 50s, you have got kids, you have got responsibilities. Life is not all the same. You want to be happy and safe. It's very nice to drive a car when you're in your young age at 80, 90, 100 kilometers per hour, but later you realize, God forbid, something would have happened. I would have not lived to have a good family with me. So this is where we have to be very careful. And fire safety is no less. Trust in God is very important, but blind trust is also not very good. So we should pray, and India is known to be one of the secular country, praying and working hard. I'll come to a very technical question for a while. We look at international codes, we look at global projects. I'll just put across a question over here. Very simple example of pressure in a hydrant. You've seen these hydrants which Mr. Arun was showing a while ago, the ones which were like a brass valves in which you connect a hose. In America, the pressure in that hydrant is 6.9 bar. In India, that pressure is 3.5 bar. Just for the sake of, simplicity, bar, BAR, 3.5 bar means 35-meter water column. That means on the nozzle, if I make it stand vertical, the water will go up to a height of 35 meters of water. 69 bar means the water will go much higher. That means the pressure in an American hydrant system is much higher in comparison to an Indian code. Now, when you become project managers, when you work on projects which are international in India or otherwise, you will say, Mr. Consultant, I want the best. So, Mr. Consultant will say, you have got two figures to choose. What do you want to choose, sir? And I'm not very sure what would you choose. So therefore, so that you do not make that mistake, and let's say for some reason you say, I like 6.9 bar because I think America is better than India, and what this consultant may go by what you have said, what you get by the Mr. Consultant's design is this. So when you do a 6.9 bar in India, my 70 kg of a fireman will experience what you see there. So typically speaking, if you ask me, in the Indian conditions, the fireman is not able to take up the advantage of a higher pressure. And this is what we'll come to. So what is the short form of the learning? When in Rome, do as Romans do. We learned this when we were in class 5th, 6th, 7th, 8th, but we forgot this. Because we thought what you do in Rome, if you do in India, is also very classy. Sir, that's not the case. India has got its own USPs, its own privileges, its own way of doing things. What is in America is 115 volt. In India is 230 volt. It does not mean that India is better or America is better. It's the way it happens in that part of the world. We cannot replicate what is happening in America or in Europe or in Dubai or in Australia in India. We have our own guidelines, we have our own time zone, we have our own left and right steering wheel drives. We are India, we are India. So the point remains that if you feel that this is the problem, that's another thing. Although we are on a virtual mode, but I would like to educate you something little bit, which is my passion. Perception and reality, many of us think we are Superman. In reality, we are very simple human beings. And then I put a question to my audience, if there is a fire in the building, what will you do? I've been repeating this question for maybe last 8 years. but I don't mind repeating it till the time I don't get one answer from the entire community sitting in the room. And I ask them that if there is a fire in the building, what will you do? Will you will you go to the terrace? Will you remain in the hotel room where you are? Or you will go to the balcony? Where will you go? And this is a question which I ask my Codians, and I ask this question and I get different answers. It is like the KBC question, choose your option. And I get different answers. And honestly, it is little fun, but it is equally sad because I don't get one answer from everyone. And I say, many of people whom I put this question would like to say they go to terrace. Excuse me. My answer to that is going to the terrace is going near to the gods, because at the terrace you are the farthest from the earth. And you know where your mother is? Your mother is at the earth. That's why we call it Mother Earth. This is where we have started our lives from. So, in case of distress, don't go away from your mother. You have to go to the ground. If you see any of the international or national or any of the buildings in India or abroad, you see this beautiful sign, assembly point. Always you see this sign on the ground outside in the green areas, in the green lawns. You don't see this sign on the terrace. See this? This is where the sign is. It's always on the ground. So you assemble in case of emergency at this location. Internationally, so my dear friends, today, tomorrow, day after tomorrow, you meet your friends, you meet your family. In case you are in a building, in a mall, watching a movie, or shopping, or in a hotel, or God forbid, in a hospital, if you have to save your life, please go to the ground. Because if you go to the ground, you will go home. If you don't go to the ground, you are depending on somebody to rescue you. And that somebody may or may not come. So, therefore, please be practical and go to the ground from today onwards. Please keep this absolutely to your knowing and to your practice. Now, I'll come to something interesting. You know, BS 9999, we see international codes. It talks about different types of occupancy classification. You may be able to see the screen right now on the back. I'm sorry. It talks about different types of occupancy characterizations. People who are familiar with the building, who are awake, people who are awake and unfamiliar, people who are wanting to be, who are likely to be sleeping, people who are medical care and in transit. So this is the way internationally they look at occupancy characterization. And based on this occupancy characterization, the fire safety of the project is being planned. In India, we may not copy what they do. We have got our own 9 different types of occupancies: A, B, C, D, E, F, G, H, and J. Please understand, in India, BIS, we do not use L and I in our codes, and we limit the use of letter I and letter L because it can create a confusion of Roman numerals. Therefore, after H, GH, you don't see I, you see J. This is very interesting. A lot of people call me, they talk to me, they say, Sandeep, there is a mistake. There is I which is not mentioned. I said, sorry, sir, it's not at all a mistake. Please refer to IS5. IS5 describes you how to draft a code. And IS5 mentions that alphabets like L and I are not used in the codes as a part of our practice. Now, different types of occupancies. For different types of occupancies, we also have got various kind of structural ability aspects. How the building has to be designed structurally so that it should not fall. Please understand, you will protect a building from fire only if the building is standing. If the building collapses, what will you protect the building from? So it becomes immensely important that during fire, despite fire, building should stand and should not fall. Because a fall building will result in more catastrophic problems of the structural collateral damages which will occur due to the fall of the building. So the first thing which occurs in the National Building Code of India is the structural integrity of the building. The building should stand even though is on fire. So if we fight the fire and we extinguish the fire, the building remains in its structural composition in its structural profile not to collapse. Something to learn again, you have got Indian codes, you have got international codes, how they define the building which should be defined in terms of its columns, beams, and its roof and also the slabs. There are various numbers. Life is more simple. So if you do a type 1 building and you call up your friend, let's say in US or in Europe, and you say, I'm working on a project where the building is 442. The gentleman knows that the column is 4, the the beams and girders are 4 and the floor is 2. So if you see 442 means 4 number 1, 4 number 2 and 2 number 3. In this row and column matrix, it is very easy to predict and to know. 322 will means columns 3 hours, beams and girders 3 hours and 2 hours beams and the floor slabs. So depending upon the height of the building globally, these kind of numbers are being picked up. So let me just say, for sake of argument, a typical hostel building probably could be triple two because the building is not very high, the building is not very tall. Whereas, which is a building which is like 15, 16 meters, some 4 or 5 stories of a hostel building could be triple two. A hospital building could be double three two because that building is having a lot of patients in it. A iconic building like a Burj Khalifa or a tall office building which is like 50 stories could be double four two. So what happens in this case is that we try to optimize the structural rating of the building, not just spend too much, but also to control the cost depending upon the risk the building will have in case the damages of the building will happen. So these are the various ways where code givers are able to provide for the various types of ratings, and the structural engineer defines the construction of these components to result in those kind of fire rating requirements. I'll give another very interesting slide. You could see various tall buildings in the world. I could show you, these are the tall buildings which you know very well from your practice and from your studies. And this is what these buildings fire ratings are like. So if you really see, in those days, the buildings were 3 hours and the floors were 2 hours. So what happens in this case is that you have got buildings like Sears Towers, which were columns of 3 hours, floors of 3 hours, and you know which year the Sears Towers was done. So there was a lot of debate that the cost of the building has gone up because of the fact that the floors were also with higher fire rating. So overall, then there was more value engineering. These are the numbers. I'm sure globally there's more work going on this with the kind of threat, the terrorist attacks, and the other kind of vulnerabilities. These numbers are again being looked globally, but we should know where we stand for our kind of working and requirements. So this is how it goes about in terms of it. It's Mr. Arunji, you look at Jingmao Tower, it is 2000 square meters of office area and compartmentation. So that's another interesting thing to see how they are defining compartmentation per floor. So smoke compartmentation and this compartmentation, I will come to another topic where we talk about compartmentation becomes how relevant to control the fire. Some another interesting pictures. When we do not know things rightly, we tend to do wrong. Air conditioners over here can actually burn and actually can add fire back into the building by the glasses, as you can see. You know how many problems we have of the air condition burnt out. Rather than on the terrace, if we start putting them, bulk of them in the balcony, one air conditioner heats the other air conditioner. So one air conditioner is fine, but if you put 5 of them together, you could imagine the risk we are bidding in. NBC does not limit you the number of air conditioners in the balcony. Maybe we made a mistake. But how many such mistakes can we correct ourselves as well? We are all engineers. We need to understand. Putting too many eggs in the basket could have all the eggs broken together. This is one problem. You have got problems where you have got bulk of air conditioners like this. So where is the problem? The NBC, is it not allowed as per NBC? My answer is NBC is silent on this. NBC is silent. How much could we write? How many pictures we will take to Mr. Arun, Mr. Pant and say, let's not allow this to happen? Do we really need those kind of guidelines to be given to us? I'll tell you some more examples where we have given guidelines. Despite that, we have failed. I'll tell you some more examples. The NBC very clearly states no electrical cables in the staircase. Forget about anything else. You see this staircase and you see this door. Inside the door is the electrical panel. I'll tell you right now, maybe you'll not be able to understand how severe this could be. But after another 10 minutes, you will never permit this ever in your life in any of your buildings. And I'll prove you how you will be doing that. The fear of unknown. We have provided a sprinkler. This is just a pictorial to make you understand. Here is a light. Here is a sprinkler. And the engineer is much worried. So he has provided also a valve behind the sprinkler. So my dear friends, these kind of pictures make you laugh. But imagine the valve is closed. There's no water there. And imagine your family is there for watching a movie over here. This is the Bangalore airport. I don't have any shame to tell. See the sprinkler there? Unfortunately, if the sprinkler works, it's going to go around like a snake. This is another picture from the Upahar tragedy. The consultant thought that he has to pressurize the staircase. So what was done, where Ms. Neelam Krishnamurthy lost her two children, that they provided a fan inside the staircase which was sucking the air from the auditorium. Can you imagine the plight of the mother? This fan should have enabled to be put on the other side of the wall so that smoke does not enter into the staircase. This fan would have actually helped you to push the smoke outside by pressurizing the staircase. This, as you can see, this is 54 number figure which Ms. Neelam Krishnamurthy presented to the Supreme Court, mentioning the flaws because of which people got killed. The kind of research she did, despite not being neither an engineer nor an architect nor a project manager, because the children were lost their lives, she presented the facts to the Supreme Court, mentioning the flaw because of which people lost their lives. This is very painful. I'll show you an example. Here is a fire door. All of us can see it. It's got a fire panic bar. It also has written very clearly, it's a fire door. It mentions that it also has a door closure and it also has a door stopper. Now, when I saw this picture, I came back to the BIS and I said, we have to introduce this clause. And the clause was as follows. Door stoppers in exits will not be allowed. In this picture, I'm really sorry, I was not able to take a little bit inside on the left side of the picture. Maybe you can visualize some car standing there because that's a car parking door. And if this door is the way it is, you could imagine if the car catches fire, what would happen in that scenario? This is what the situation will be. So the door is in open position. It was to keep the fire outside the core of the staircase. And by us introducing that door stopper, we have made the passage for the fire to enter into the core. And now you are using the staircase to come out of the building. Can you use the staircase to come out of the building now? Answer is no. So the staircase has to be holistically compartmentalized to keep any possibility of fire to enter into the core of the staircase. I'll give you another example over here. How could this mistake happen? Here is a staircase where they have provided electrical meters and they have also provided an extinguisher next to the meters and also a dustbin. You see, please understand, young boys and girls, and maybe we will have also professionals eventually watching this video. Somewhere we are to be mistaken for this. Now, where will you say NBC has not mentioned? NBC clearly states no electrical services inside the staircase, except for the light which will glow inside the staircase to light up the staircase. That's all the wire I will allow you to put in the staircase, because that is providing the light for the people to provide an incandescent bulb, a CFL, or an LED. That's all. Should I put that there should be a torch inside the staircase? Well, I can't do that. If I was to given a chance, I will put torches inside the staircase. There should be zero electricity because any spark in that could create the staircase to become vulnerable. If we do not understand the requirements so clearly, I met somebody who said, I said, why you have kept a dustbin? He said, where it is written in NBC, dustbin can't be kept. I said, yes. But then after 10 seconds, I said, sorry, NBC says storage is not allowed. So this is garbage storage. He said, now I will remove it. So that is something which, as a society, we have to be very conscious about. I'll give you some basics. Now let's not, because this is not this is more or less like an online. Architectural safety, we're talking about life safety, construction. MEP, we're talking about smoke, fire alarm, fire protection, elevators, electrical resilience, glass facade. Please understand, we are very blessed to be working as architects, engineers, and maybe in this society where we can contribute. I've been working for 30 years. Every time I get a drawing, I feel very happy because we can add a little bit more to make it safe. So this is where, we work around on things. And I'll just give more time, a little bit more. Life safety is something which is zero tolerance. God forbid you do not have a sprinkler somewhere. I can still do it after 2 months. Maybe yes. But if the life safety part of the building is missed, staircases are not put correctly, you do not provide the right kind of construction, you provide electrical panels inside the staircases, those corrections cannot be done. So typically speaking, also in MEP, you have got zoning, you have got gas suppression system, you have got emergency lighting, you have got fire lift, kitchen safety, refuge area safety, fire control and command. So there is so much which has to work together like the gear of a watch. If your watch has to show the right time, the various gears also have to move with the right pattern to provide you that correctness in the functions. If you really see one more thing importantly, we have this myth, as I said a while ago, thank you. We said a while ago, nobody will come and rescue you. Globally, if you really see, Dubai has got staircases which are 53, let's say about 12 story, Hong Kong 52 stories, Chicago 31 stories, Abu Dhabi 54, Singapore 53. Unfortunately, in India, 90 meters. We buy 90 meters because we enjoy buying things which are big. But tell me, do you have infrastructure on the road to drive those vehicles? We don't have it. Making buildings to provide that kind of an infrastructure is not possible to do. So what you see is only the low height of the building where you could still be rescued. But what will be the guarantee that you will be rescued? Very unlikely. 29 people, 290 people, 2,900 people. You are one of them. How do you know you will get out of the building by the help of the fireman? He may not see you as a priority. Your tears will not make his heart to bring you down. Maybe a child is there, maybe a pregnant lady is there. They will be the priority. And you will also not like the child to die. So you see, it becomes a very emotional tangle. Who is going and who is not going? There's this nice movie which probably is not there now any further, Towering Inferno. There's some Hollywood movie, people were to be evacuated. It becomes a very emotional tangle. How do you actually make people go out? You say, no, you go, I'm not going. No, I will go, but you don't go. So the best way is go down. So typically speaking, this doesn't work. Some fundamentals, you are in a building, it's got 2 staircases. You are sitting in a meeting room, you are sitting in your classroom, you are staying in a hotel. These 2 staircases, let's say in your building, are the ones which will help you to come down. And as I said, you're going to walk to the staircases, which is known as travel distance. A lot of architects and engineers are familiar, travel distance. 45 meters for sprinkler buildings in most of the cases. So you walk 45 meters to the green box. I've just highlighted one green box, but there's another green box. So I'm just highlighting for the sake of clarity, one green box on the right hand side. There's a similar green box on the left hand side. This green box, I always say, the space will be having eventuality of fire. You will walk from here into the exit, and this exit, I always say, is the temple of the house. Keep it clean, neat, no elements of storage. If you take care of the staircase, you will come down to the ground. You might be on 15th floor, you might be on 50th floor. All you need is a core which brings you down to the ground. And if we are not sensitive about the safety of this, it's very important. National Building Code of India, we are now even providing detectors inside the staircase so that in case there is a fire or smoke which one can notice, a PA system also helps you to manage the crowd. And we say in such scenario, this staircase will not to be used. So typically speaking, it has to be also a human effort and also your own skill to learn safety. It cannot be taught to you in 15 seconds when the fire is occurring. You have to listen to PA announcements. It has to be, as I said, it is a chain reaction. One broken chain, one broken lug, the chain will break. This is what is going to be happening. And this is where we see buildings, and I feel very worried when I see buildings like this. You can see in this building, there's no door. When there's no door, what will happen? If there is a fire, that fire will go around in the building and you will not be able to go out. So in your practice, you need to have staircases which are enclosed. I'll show you another example. Where is this enclosure of the staircase? It's an open staircase. An open staircase definitely is very high risk. You see this building scenario again? This is All India Institute of Medical Sciences, AIMS. People are standing with prescription, going up and down the staircase. Without a door in the staircase, the whole staircase is going to become inferno. Travel distances, how do we measure them? We measure travel distances. Many of the consultants and architects measure B. They say we can't do A because we do not know the furniture. But if you do not know A, please don't do B. You can do C. We learned in our college days, hypotenuse. We learned the right angle triangle rule. Why can't we follow this? This will give you more accurate results after A is planned. But if you do B, you will definitely fail. So why don't we do C? In all our projects we do at our office, my engineers are asked to follow the design of C. It is painful, but it warns you that later you will not fail. But if you do only B, there is not only possibility, you will fail for guarantee. So this is where we have to learn. National Building Code of India does not teach us this. You see, there are certain things which cannot be written in code in binary. There are good things to happen. There are buildings which could be complex. You may be having a hall. You may not have a furniture. You may say, I don't need this B because I don't need the C or A because I am on B. We are doing Kirtan. We are going to sit in a hall. Fair enough. But how could National Building Code of India start explaining you things which are not viable to do this way? I will ask, obviously here I can't ask, but I would definitely, we have got some audience over here in the room and maybe, we'll not be able to interact right now because a lot of people are there online. So people die because of smoke. And I would ask that there has to be something with which people should not die because of smoke. I have this classical question, people die because of COVID. So what happened? We should do something so that people don't die because of COVID. Maintain social distances, wash your hands, take an injection, take the vaccination, you are done. So what should be the magic that people don't die because of smoke? So I go to a lot of professional technical seminars and I ask this question. I get different answers. But the answer which is the best to come out of the audience is this word. Very simple, compartmentation. And this comes to you very clearly if you see this box. When your mother used to give you the lunch or the breakfast for your school, In olden days, this was not the way we used to carry. This was many, many years ago. We used to carry plastic boxes, but that box still had compartmentation. Compartmentation for food not to mix. And this is what we need in a building. When you need, the food is in front of you. When you need to compartment, you need to be compartment. And once you do this, you follow this strategy. The next diagram will become more clearer to you. This is what you do. So it's like heaven and hell. Right is the heaven and left is the hell. There is a complete demarcation between the two. This is the best diagram I've ever seen in my life. Let the building be as big as it could be, but the fire remains confined. I don't want to say this, but I don't feel ashamed in saying, if you do this, you don't need anything. You don't even need a sprinkler in the building. Firemen will come, they'll extinguish the fire, something or the other will happen. If you have this, my dear friends, you don't even need a staircase. You can just move to the next compartment and remain there, because that box will be 2 hours safe. So what happens, and I give this example of COVID, when we had COVID problems, the person who had COVID was isolated. That was another word of compartmentation. We segregated, the world was one. We were having people flying from one country to the other. Countries compartmentalized, cities compartmentalized, blocks compartmentalized, floors compartmentalized, rooms compartmentalized. Everything was broken to the last bit. And the person who had COVID, I had COVID, was put into a room. Food was served from outside the family. Compartmentation is done for 14 days, and you are back with your family again. What COVID taught us was also, I'm going to come ahead and tell you, one more important thing in fire safety, which I will talk to you in a while. Compartmentation was one thing. Then you have got National Building Code of India, which prescribes you the compartmentation strategies. Look, my idea is not to teach you the code. Code, you can learn these numbers yourself. Concept wise, we should know what is travel distance, what is exit, what is compartmentation. These numbers over a period of time will change. 1800 might become 1500, it might become 2500. That's all a part of our working profile. But the strategy of compartmentation will remain perpetual for next 100 years probably, or more than that. You have done compartmentation of places like this. This is a place in Singapore. You could see as if there is no compartmentation, but in case of fire, there is a fire barrier where the curtain will drop. I'm sorry, the arrow is in the reverse direction. I should have done it the other way around. That's a mistake. So the curtain drops from the top and the door allows you to pass from the curtain, along the curtain. Similarly, in compartmentation, air conditioning plays a very important role. These ducts are over the brick walls. If you do not do proper compartmentation with fire dampers, you might have a fire door, but you might have a breach of compartment over the fire door. That's another important aspect to look into. Major requirements are compartmentation, exits, staging places, power supply, dependability, and resilience. Most important, what I like the best is the PA system. And this is what COVID again taught us, public address. Prime Minister used to be on his Man Ki Baat, and everybody was following the instructions of the Prime Minister without any revengerance. That is what made us stand that time. I'm not a Prime Minister's to say so. I've got my technical things to do. I don't follow politics. But I learn from it. Communication was the most important thing which kept us together as a country. And at that point of time, that was best to do. I do not know politics wise what is happening, because I've got many other technical things to do. I'm least interested in politics, but I learned a lot when it was a good communication. Similarly, if you talk about smoke mitigation, you have got smoke mitigation where you are able to mitigate the smoke. 10 minutes more or only? How much time? Yeah, 10 minutes to close. We have got smoke. So we want to talk about how do you want to manage smoke. A lot of people say people die because of smoke, people die because of smoke. Look, people die because of smoke. But if you have got a right strategy to isolate the smoke, you can save lives. And isolation of smoke will happen by compartmentation. If you are able to put the problem into a box, you don't have the smoke going around. In India, we have a major problem. We don't care of compartmentation, and our buildings are slowly becoming more and more air conditioned. The more the air conditioned buildings, the more the likeliness of the smoke to remain within the building. And if you do not have a compartmentation strategy, you are likely to kill people because the smoke will spread within the building drastically from ground floor to first floor to third floor to fifth floor. And that smoke is going to be killing people because we do not have the Lakshman Rekha defining the compartmentation in any of our plans, unfortunately, by any of the design engineers or architects. So as I can tell you, there are two things over here. Human occupied spaces, you have got to have some kind of a ventilation stuff. That ventilation is also there to create temporary tenability and to ensure that human beings are allowed to reach to the exit. How much time do you think you will take to reach to an exit? Since this is not an interactive session, I'll give the answer to you. Less than 90 seconds. Less than 90 seconds, I can put my hand on the table and say, hand on my heart and say, if you whistle and you tell people to go to a staircase, and if the staircases are planned properly, located properly, and sized properly, you, I, me, he, and she all will reach within 90 seconds into the staircase. So, therefore, this smoke management situation for a tenable area is only for that, what we call it like in a case of a cardiac arrest. You have got a golden period time. If within that time, if you are able to provide medical help and support, the patient is able to survive, right? So similarly, if you are able to do smoke management for a very small span of time, people can reach to the exit and they can get out of the building. That smoke management system is not going to work for 30 minutes or 40 minutes, because it is assumed that after that duration of 2 minutes, 3 minutes, human beings will not remain and they would have evacuated the space. So smoke management system is just to aid to some extent people to be able to reach to the exit. It's like a lifeline for a shorter duration. So one has to understand that. Whereas the green box, what you see, will work for more than 2 hours, because that green box is keeping the smoke out of the green box to enter into the green box. So the green box is what we call it pressurization. Pressurization is of huge importance in a building because that keeps the smoke away. But believe me or not, you can pressurize only small spaces. You cannot pressurize large spaces. So therefore, pressurization plays a very important role. Then of course, we have done some studies. Maybe you will not be able to see it very clearly right now, but just the numbers I'll tell you. This is known as pre-movement time. What is the pre-movement time? I whistle and I say, leave the building. Go to the exit. I'll help you to understand. In a building which is like an office building, you will take time of 1 minute. Now 90 seconds plus 1 minute is 2.5 minutes is you will take to reach to the staircase. Because 1 minute you will take time to understand ho kya raha hai. You will start realizing that you have to evacuate. So that 1 minute plus another 90 seconds, 2.5 minutes is the time you're going to be in the exit. That is pre-movement time of 1 minute. Therefore, NBC presently has not prescribed smoke management for office buildings predominantly. Reason being, 3 minutes mein you will be in the exit. Now, let me take another example. Sleeping accommodation, which are like hotels. How much time will you take? 20 minutes. Very likely. 3 o'clock in the morning, you are sleeping. You have put your nightwear, you are sleeping, you had a long day, you are in deep sleep. You have to be woken up. If from your sleep, you will get up, you will get aware of what's happening. Maybe, you'll opt to pick up some of your things because you just can't want to leave them. You'll change your nightwear. You want to come out of the room. You want to walk out of the staircase. All that put together, 20 minutes. Pre-movement time is 20 minutes. Add another 90 seconds. So, pre-movement time in hotels are 20 minutes. So, smoke management system in a hotel becomes mandatory because it needs you that kind of a time where you can be given environment for you to escape out of your room. So, this is where the rationale of a smoke management is driven from the pre-movement time of the requirements. It cannot remain मुझे यहाँ भी smoke management, होटल में भी, ऑफिस में भी, स्कूल में भी, रिटेल में भी, residential में भी. 9 types of buildings, my dear friends. You just can't say I want in all the 9 buildings. Well, you can say that, but that's not right. It's not fair for you to say in all the 9 buildings, please give me the smoke management. That is the problem. So one has to be conscious about what is asked for what type of occupancy. One last thing over here. In India, we have got this concept right now of area of refuge. You could see this building. It's right now many buildings in Gurgaon, Hyderabad. They look like this. Bombay, they look like this. Now, what we slowly realize that these are the buildings in which we have created these areas of refuge, and these are being predominantly done like this in the building, horizontal yellow bars. And these spaces, when you say refuge areas, are meant for people with temporary or permanent disabilities. These are all people with temporary disabilities for time being. Now, if you create refuge areas like this in a building, would this mean that other areas in the building, which are these floors, are not to be occupied by these occupants? Am I prohibiting their entry into these places? Is this what I want to do? I do not have the answer. You have a friend who has got temporary disability. He works on a floor which is in the red zone in the accounts department. He comes through the elevator from the car parking area and he comes to his office desk and starts working. Now there is a fire in the building, but this person is working on a non-refuge area on a computer. He cannot use the exit staircase. Now I want to ask, in case there is a fire in the building, you, I, he and she will all be expected to go to the staircase and exit out of the building. What will this gentleman do? What is the directive to the fire control command for this person on that floor? This person is on the yellow floor, no problem. You can take him to the refuge. But who says that he will be on the refuge floor? There is an old man who is visiting a office for his pension related matters. He's sitting in the accounts department from 3 o'clock to 5 o'clock in the afternoon. There's a fire. This old man can't run like you and me and get into the staircase. What do? You say, sorry, if you are in these categories, you can't go to these floors. Sorry, not allowed. Can we do that? Not possible. Not possible. So what did National Building Code of India did? National Building Code of India introduced you what is called as fire tower. A fire tower is what you see on the screen. It's got a staircase, it's got an elevator. After many years of our practice of this, we have happily now put in the yellow line over there. This is the area of refuge. This is available for those people whom we just talked about to be brought and to be staged. Right? The possible shape of things to come, possible shape of things to come. Area of refuge at all floors. Once we have done this, what have we done? These people are qualified to be here. When these people are qualified to be here, then in this building, what we had seen, we can remove this. And this building can look like this. What looks like everywhere in the world. Right? Now, having said that, this becomes the area of refuge. Vertically, what you see the yellow bar is not exactly a yellow bar. It's basically small yellow boxes within the building connected by an elevator. So what you see is good for all of these people now. Your uncle, your aunt, your brother, anybody who is not self-capable to exit the building comes to that yellow box. And once he comes there, you are able to bring this person down to the ground and probably provide medical emergency facilities. This is what the new India will be. This is what we want to do. We do not want to create those pigeonholes. My vision not to do that. We should not do it. And once I have done that, see what we have done. That yellow horizontal bars have got converted into small yellow boxes. Where is it wrong? What is wrong in this? All over the world, you see buildings like this in facade. We don't see those pigeonholes, what I showed you at the start. This is a fire tower. We brought this in National Building Code of India 2016 version, launched on 15th of March 2017, gazetted. After 2017, this has gone into the heads of everybody. People are doing buildings with fire tower. Now the time has come to give the advantage of removing the refuge floor because people have understood the uniqueness and the goodness of a fire tower. Maybe we would have failed. Maybe this was wrong. We could not have removed the refuge at that time, considering this will be successful. But now, my dear friends, after 8 years, it is very much clear this has become part and parcel of the blueprint of our projects. Now the time has come that we should step next with immense confidence, removing the refuge requirements and teaching the people how refuges could be used. Electrical resilience is a very dear subject again. My wife is an electrical engineer, she's also part of the code committee. We work together, we see every nook and corner of the building which requires electrical safety has to be done. We have a lot of arguments with architects, engineers, designers, but you see, it becomes very difficult to explain people. They're not willing to understand, they're not willing to learn out of the whole thing. So electrical resilience becomes very important. We have got fire alarm system, which can actually work wonderful, which can automate the things much better. And therefore, a fire alarm system is immensely important for automating the overall fire safety of the building. This is another favorite slide of mine, which is going to come. Burj Khalifa has got 18,841 people. All of them using staircases will take 157 minutes to come down, right? If they use partial staircase, 122 minutes. If they use full staircases, 89 minutes. India will move ahead today towards using elevators for evacuation for tall buildings. We have to bring that systems into place. We cannot have 18,000 people coming down just by staircases. But we also have to be correct in our planning. As I said, if you have the right PA system, right kind of practice of annunciation and announcements, you can make a very deep impact of managing the people. Whether it is managing the people in fire safety or in the country by the Prime Minister or in your office as a manager, everything is only about managing people. Students management, officials management, government management, country management, fire safety management. I think this is where we have to be very clear about our goals, our objectives, and our SOPs. So this is where we come to. And of course, as I said, electrical distribution system for tall buildings, we talked about tall buildings, is much very different than what you have for conventional buildings. We have transformers which are sitting on the upper floors. Today, transformers are so safe, unlike the Bhar tragedy which burnt, transformers of these types will never burn. And you can do more efficient electrical distribution scheme, thereby minimizing the losses and the fire safety problems as well. So a tall building is nothing but a small building sitting on top of another small building, another small building, and another small building. So if you break up the whole thing into small buildings, each of 20 floors, you can actually make 200 floors without any problem. It's just 10 buildings sitting on top of each other. That's why we create service floors, and that service floor creates for 20 floors, another service floor creates for another 20 floors, another service floor creates for another 20 floors. We have been doing projects like 350-meter tall in our practice in last 30 years in Middle East, and we find tall buildings very exciting, yet very simple to design. They are no rocket science. In fact, people are worried about tall buildings. They are much easier to do because you get much better flexibilities of providing your things. Therefore, The need of the hour, what I always have been maintaining, is basically number one is commitment. I see a lot of lack of commitment from youngsters, which includes family of mine as well. But commitment remains very important. Next is awareness. We need to be, I'm very happy that you people are attending this lecture, but my mission was to make you start the awareness into your thoughts. And the other things is very important is you guys are young, but most of the people who just slowly start practicing do not wish to unlearn. But please do not lose the enthusiasm of unlearning and relearning as you grow mature in your career. Because what maybe I have also taught you may require more corrections in future times to come. So with this, I think I really recognize and BIS to have us part of their team for more than 24 years now and take us part of the mission. This is India first, always I maintain. The country comes first. So thank you so much. And Arunji, I hope the 2025 or 26 version will be a great opportunity for the countrymen to read ahead.
Of course, wonderful. Thank you very much, Engineer Sandeep Goel ji. Um, if you have any of you have got queries, students or faculty, kindly make use of this opportunity to come in your audio mode and please ask your questions. Please do not put in chat. Engineer Sandeep Goel, in continuation to last week's lecture of Mr. Pant, wherein it was told about there are 9 groups of building occupancies and there are 3 main components, namely exit access, exit and exit discharge, and more importantly, we talked about, you mentioned about exits are your temples. Always, when there is a fire or a smoke issue, never go to the terrace. Go to the ground floor, go towards Mother Earth, and you will be saved. So, locate what is the nearest exit to you. Particularly, high rise buildings and special buildings will have 2 exits minimum. Identify them. Which is the direction to go towards them? You rightly mentioned about that. All those are given in the code, and you also talked about how travel distances should be measured. Because in a building under construction or which is planned, this is the ideal way you showed in a very simple diagrammatic manner. Also, you talked about the concept of refuge, which has been already included in the 2016 version of the code for specific category of users. And more importantly, you talked about the compartmentation. That is more important when buildings are going taller and taller. We don't want the hazard or a threat which is happening in one zone of a building to spread all to the entire building. So what are the means and ways of achieving those compartmentation, including to the level of HVAC ducts and electrical conduits, plumbing shafts, etc., how they have to be protected? You very lucidly explained to us, sir. And more importantly, you also talked about the clause number 3462 of part 4, which talks about the electrical aspects. Where do we want that redundant power supply, etc. And public address system, typically we see in various schools and colleges, the principal or the HM used to address to all the students using public address system. It is not only required for educational buildings, but for all special buildings and high-rise buildings. You very clearly mentioned about that. And also that it is not only the designing of buildings which is important, but right maintenance of all its systems, be it the HVAC system, the lift system, the firefighting system, the sprinkler system, detector system, everything should be maintained throughout the 70 years or 80 years of the building. Only then you can ensure that your building systems are up and functioning. Thanks to you once again, sir. I'll come back again to the participants and audience and students. You have any queries or questions, please feel free to unmute your device and raise it verbally, please. Or somebody who is sitting with us, any of the engineers in this room, they can also take this opportunity and let us. In the meantime, I will see, we have also put this entire today's lecture in the YouTube. I'm trying to see whether there is any question in this YouTube. I do not see one. But if take this opportunity, even if not today, anytime down the line, please write to us at ced@bis.gov.in. I repeat, it is a short form of Civil Engineering Department. ced@bis.gov.in. If you have any particular queries or questions or suggestions, do write to us on building code or for any Indian standards on firefighting or fire safety or any of the Indian standards to us, and we'll try to address them. And more importantly, your suggestions or feedback on draft standards also matter. For the students, particularly, as we told last week, The building code is only a reference book for most of the colleges. Please do visit your library, start opening it. In the first slide of my presentation, I gave you a 40-page booklet. Please do read it because it's going to come in handy for your subsequent weekly session on NBC. And I'm also told by a couple of colleges that they are going for a 10-marker quiz also. Good luck with all those students to read that 40-page booklet also. Thank you. And is there any questions from the participants in this room? If that is not there,
Is it still there? Anything anyone
yeah.
would like to know?
Yeah, we should.
10 seconds for you to, I will pause for 10 seconds. I can see maybe you're reluctant and hesitant to ask.
There are extinguishers in a building. Should I, as a user, should I operate it, or who will operate an extinguisher? That is always a question. If I'm working in an office or I'm a teacher in an institute, should I operate that extinguisher, or are there assigned people who is the person who will operate that extinguisher?
Sir, I think as a society, we should learn and practice to operate the extinguisher by adults. That is why it's known as first aid. First aid is always given by the people who can assist. It's not for the doctors do not use first aid, we use first aid. So that's why it's known as first aid. So I propose we have many societies who train, teach. In fact, within our office, we are conducting trainings for even, some kind of a medical training facilities. So I propose you should, as an adult, be aware about using an extinguisher. Of course, you should do it with caution because it has its own, it's a powerful device to use, but we should be prepared to use an extinguisher in case of distress.
Right, sir. Thank you, sir. And this particular part 4 of NBC in its Annexure D talks about fire drill. The National Disaster Management Authority and the various state disaster management authorities have been periodically instructing all the public building owners, school buildings, office buildings, and even theater owners, mall owners, etc., to conduct drills periodically. So this is a right opportunity. The interested faculty members and students should go and see that particular annexure number D of part 4. It talks about how the drill is important and how it should be carried out in a proper way. So that given any emergency which may come or which may not even come, we wish that only. Still, we should be able to get out of the building in an orderly fashion without getting into any sort of commotion or panic, because in that situation, maybe things can go awry also. So we should know how to properly, in an orderly fashion, egress out of a building. So drills are more important. That's wonderful. There is one question in or one suggestion in YouTube which says NBC 2025, is it allowing cross-referencing of international codes and standards? Even until today's date, in all our Indian standards in civil engineering and other 16 other disciplines, wherever we have taken inspiration, we have mentioned those particular international standards or other national standards in the foreword. There are ISO and IEC standards which have been wholly adopted or adapted and gazette notified by the Bureau of Indian Standards. They are written as ISO 9001 or IS/IEC 62305, like that. Those are adopted standards. Those are always cross referred in the Indian standards as well as in the building codes. And wherever there are no specific provision in a standard, users can consider seeing other technical or specialist literature for more information. So there is one query for you, I guess. Can't we put sprinklers in electrical room at floors? NBC only restricts putting sprinklers in high or medium voltage areas. This is a query from somebody, APM123. Can't we put sprinklers in electrical room at floors? Yeah.
So the answer to your query is, the answer is yes. You see, a lot of times we feel that sprinklers will burst because of any apparent reason. Sprinkler is like on standby 24/7. Only if situations become unfavorable, the sprinkler will burst. You have seen cars, ABS, you have seen also, airbags. How many times do we see airbags coming out of the cars? Only if the car hits into a very different way altogether, the airbags works. Sprinkler will work when fire will happen. And when fire happens, our prime goal is to extinguish the fire. We do not want the fire to be uncontrolled. So that fear of the sprinkler will burst in an electrical room is incorrect. Sprinkler will not burst. In fact, if the fire happens, the sprinkler will only control the fire by minimizing the damages. And don't forget that electrical safety wise, if there are ELCBs and other systems provided, even if there is a little bit of earth leakage or something, the panel will trip. Yes, I could understand if this panel is feeding to an operation theater. Then we will not like this panel to trip. We may like to take manual intervention in extinguishing that fire. So conventional electrical rooms, answer is we should provide sprinklers.
Feedback from the same person, APM 123, is however, people, including consultants, are not in favor of putting sprinklers on those areas or rooms. Neither they, and they say, neither room flooding system. So that means they're not providing any of the protection system.
Yeah, I think Arunji, that is something which is a little bit of again fear factor and unawareness. I would use the word. If you go by global codes, they explain what I have just said. Unless the panel is feeding to some mission critical activities, some specific server, it's a different. Then there is where you need clean agent systems.
Right. Is that what we see typically in Delhi metro rail stations? Near the panel, there is a red color pipe which is going.
Absolutely.
And that is one. Okay.
Absolutely, sir.
We in Delhi particularly, most of us use this metro station. We see on the platform a distribution door, and there is a red color piping which is going in all the time. And that is nothing but a fire extinguishing media, which is readily going into it. In case something happens, it will come into action. Okay. Okay, it's already 5:45. I thank you everyone formally, those who are present in the BIS green room here in headquarters Delhi, and all the faculty and student members who are MOU partner institutes of the Bureau of Indian Standards, 95 institutes in number, and also all the audience in the YouTube for making it to this second such discussion on the part 4 of National Building Code of India. I especially thank once again Engineer Sandeep Goel for sparing his valuable time. And next week, we'll be having a third lecture on the Part 5 building materials of the National Building Code of India. Not only on Part 5, we'll be focusing on other related Indian standards on building materials. Thank you and stay connected. You'll be getting the flyer and registration link for the next event. It will be again on next Friday at 4 p.m. Please watch out our YouTube link who are other than MOU partner institutes. For MOU partner institutes, we'll be sharing the flyer as well as the link. Thank you once again and good evening.
Minuta no, minuta no.